Question number 20. In the figure below, line AB is equals to 10 centimeters and is part of a trapezium ABCD. Point X is such that angle BX is equals to 45 degrees. So the angle is done, line AB and point X. Part A, using a ruler and a pair of compasses only. 1. Locate point D on line AX such that AD ratio DX is equals to 3:1. So let us to begin by locating that point given the ratio. There is something that you're going to use in order to know the location of D. You're given line, that is we have A and X is there. So given this ratio, AD dx is equals to 3:1, there's something that you're going to notice. And looking at these, you'll note that D is dividing line AX internally. Why do you know that? By just looking at the position of A and X. And also, if you want to get AD given this ratio, AD will be given by 3 over total is 3 plus 1, 3/4 of AX. And then dx will be given by 1/4, looking at this ratio of AX. That is how you notice that this point D divides this line into 4 equal parts. So you have to divide it into 2 first. In order to divide it into 4 equal parts, first bisect the line AX, and then since you're interested with point D, looking at this ratio here, 3:1, AD is 3/4 AX, 3/4, you have again to bisect the other half there, and then you have these. So these are 4, 1, 2, 3, 4 equal parts. So AD is 3/4, 3/4 is 1, 2, 3, so D will be somewhere there. So now looking at these, you'll be able to locate, looking at this ratio, to locate point D. So to get D, you need to divide line AX into 2 parts, that is bisect it, then again bisect the upper half, and that is when you obtain D. So that is what you're going to do. So let us do that. So to bisect AX, stand here, the pair of compass, make sure you open it for more than half of that line, then mark an arc there and another arc, then with the same radius without changing it, stand that point, then cut that arc and cut that arc, then join the point of intersection of the 2 arcs using a straight line. Join it using a straight line, and this is what you get. That is what you get. I have not done it perfectly. We do it a better way. Sure that the line passes the center point of intersection of those 2 arcs. So that is how it's supposed to do it. So divide it into 2, then the other half, also bisect the other half by standing there, opening it more than half of that line, and then mark an arc there, mark an arc there, then in the same radius, without changing it, cut that arc and cut the other arc. So when you bisect that half, so that is how you get it. So this will be point D, this is point D. So start by bisecting this line. You bisect the line, then the upper half again you bisect it, and when you bisect the upper half, you locate your point D there. So you've located it. Then part 2 of the question, complete the trapezium ABCD such that line DC is parallel to AB and angle ABC is equals to 67.5 degrees. So the point here, well, the point of concern is ABC. Angle ABC should be here and it should be on the left hand side. So how do we construct 67.5 degrees? Now to construct 67.5 degrees, again, going to demonstrate how we do it. You have point B here, so you have to construct 90 degrees first. Then after you construct 90 degrees, you bisect it, bisect the other side on the right hand side, you get 45. So the whole of this angle that remains here will be 135, and 135, when you bisect it again, that is when you get 67.5 degrees. So you construct 90 degrees first, then 45, then the other one that remains is 135. So bisect the other side, that is how you're going to bisect it, and you get this one is 67.5 degrees. So that is what you're going to do. So we'll begin by extending. We'll extend this line. We extend the line so that I may construct 90 degrees. So to construct 90 degrees, of course, you stand there, mark an arc, another arc. So mark this arc, the other arc there. Then standing on this arc, mark an arc there, the same radius. You're changing it at that arc. So from here, that is how you get 90 degrees. So that is 90. Then you bisect 90. So you stand here, bisect it, mark an arc there, and another arc there. So this is how you bisect. So by marking standing here, repeat it again. So this is a mark an arc there, another one there. Then standing here, you mark an arc there, and then you cut that arc. So that is how you bisect it. So you started by marking this arc, marking that arc, then this arc, then standing on this arc, we've made that arc there, then the same radius, that arc. So this will be 90 divided by 2, this will be 45. So that is how you get it. So this will be 45 degrees. Now when we bisect the whole of the other angle that is remaining, we will have 67.5. So to bisect it again, you stand there, you mark an arc, and then on the other side you mark an arc, then stand on this arc that you made here, mark an arc there, then on this mark an arc there. So when you join, draw it properly. We draw the arcs again here. Yes, otherwise okay. So these should be now 67.5 degrees. Now after doing that, so we have constructed 90 degrees, then 45 on the other side, then we bisected the other one, 135, to get 67.5. After doing that, we need now to complete the trapezium ABCD. AB, so C is supposed to be somewhere here, then D here. So you know the property of parallel lines, that you given any two parallel lines, the distance between the two parallel lines is supposed to be constant. So meaning that this distance here, need to take this distance, because the C is supposed to be somewhere here. So that distance is supposed to be the same or constant. So to get that distance, I will stand here and I will drop a perpendicular. So mark that arc, mark that line B. So we are dropping a perpendicular from D to AB. It is a part of the question part 3, but I'm using the same part in order to locate point C. So standing at D, mark an arc on that line and the arc, then again standing here on this arc that you've made here, mark an arc, and then with the same radius without changing it, stand there and mark an arc. So then I join this point of intersection of these arcs like that. So these will be a perpendicular from point D to line AB. What I am interested in is this distance here. This is the distance that I'm interested in, because when you give it two parallel lines, the distance between them is supposed to be constant. So I need to take that distance and then I transfer it here using this line that I used to construct 90 degrees. I mark because the C is supposed to pass through there, although it is not part of the lines of the trapezium, but it's going to help. So when I draw a line like that passing through this point, you will notice that C will now be here. C will be located here. This is where we have C. And since I've taken this distance between DC and AB should be the same. This one, when you look at it, you can see that distance. This distance here, this distance should be the same, such that this line is parallel to that. So that is how you locate point C, and ensuring that DC is parallel to AB. I've used this distance here, and the line that I've used to get that C is this line I used to construct 90 degrees. Now you notice after doing that, I have already answered another question on part C. This is a part 3. Draw a perpendicular line from D to meet AB at E. So that line is the one that is here. So how did I draw this? I stood here with a pair of compass. Then I made this arc on this line, these two arcs, this arc and this arc. Then standing on this arc, I constructed that arc. Then standing on the arc with the same radius, cut this. So this is how I dropped the perpendicular. And now this is a point E. This is a point E. We need to measure DE. So you need to measure DE. So DE. So you can use a ruler to do that. So that is a 4. This you can see this is around 4. Let me take it using. We take that measurement using a pair of compass. Around 4.1, giving 4.1. So we'll take that distance there. This is the distance you take using and you transfer it here. you know, it is around 4.1. So DE is equals to 4.1 centimeters. Then calculate the area of the trapezium. How do you calculate the area of trapezium? ABCD. So area of trapezium is given by a half times the sum of the two parallel sides times the height. So we just use this formula, half times the sum of the two parallel sides. We just need to measure them. One side is AB, and AB is here. It is 10. AB is 10. Then the other one is a DC. The other parallel side is DC. And when I look at DC would be 4.1. DC will be 4.1. 4.1. Then times the height. The height is perpendicular height is this DE. DE is the perpendicular height, which you got as 4.1. So these will give, using a calculator, will be a half times, this will be 14.1 times 4.1. So we multiply these using a calculator. So 14.1 times 4.1 equals to, and divide by 2. We'll get 28.91 centimeters squared. That is the area of the trapezium. That is how you're supposed to solve that question.